Alright, so let's go through the 5.1 worksheet, everything we need to know heading into section 5.1. So, the first section of that worksheet is name 4 ways in which the fundamental trig identities can be used. First thing that we're going to be using trig functions in not just 5.1 but in all of chapter 5 is to evaluate trig functions. So we've already done this a little bit, so things like tangent of 45 degrees, we can evaluate that. Alright, so evaluate is when we already know some of the values and we're going to turn it into an answer. The tangent of 45 is 1. Okay? Second thing that we can do is we can simplify trig expressions. Alright, so when we don't have a degree, if we just have the tangent of x, right, that's already simplified. That's as simple as we can get. So we're going to take some more complex trig expressions and see if we can simplify them down into our basic building blocks: sine, cosine, tangent, secant, cosecant, and cotangent. Third thing we're going to do is develop additional trig identities. So we're going to take our building blocks, the sine, the cosine, and tangent, and we're going to plug them in and move things around and see if we can come up with some new equations, some new expressions. And lastly, we're going to use it to solve trig equations. And this is going to be a lot of what we're doing. So anytime we had an equal sign, what we've done in the past, we've had something like this. Tangent of x equals 1. We would be able to use the inverse tangent of both sides. And we could solve for x. We're going to do a lot of that, but things are going to get a little more complicated, not just tan, but tan squared, things like that. So, to do those 4 things, we're going to need some basic building block identities. And so they're going to start right here. So the 6th, let's start with reciprocal. Remember what reciprocal means? Reciprocal means flip it over. So these are the flip equations. What's the flip of sine? Flip of sine is cosecant. Flip of cosine? Secant. Flip of tangent is cotangent. And then the last 4 are going in the opposite direction. So if the flip of sine is cosecant, the flip of cosecant is sine. If the flip of cosine is secant, then the flip of secant is cosine. And if we start with cotangent, that's the flip of tangent for those 6. If I'm going too fast at any point, feel free to pause the video to get everything down. But let's move on to the next section. List 2 quotient identities. So there's 2 fractions out of sine, cosine, tangent, and the reciprocals that can be built by sine and cosine. And the first one is tangent. Tangent is sine divided by cosine. Because if we remember, tangent, when we were using the unit circle, is y over x, and if you remember, y is sine and x is cosine from the unit circle. Conversely, cotangent is the flip. Instead of sine over cosine, cotangent is cosine over sine. Alright, so then we're going to have 3 Pythagorean identities. We use the phrase Pythagorean because a squared plus b squared equals c squared is where we start from to get these. Now the why of this, why these are true, is fairly complex and involves some proofs which we can look at if we're really interested, but for the time being, for now, we want to just have these memorized and in our tool belt. So the 3 are sine squared plus cosine squared equals 1. The second option is 1 plus tan squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. One thing that we want to mention right off the bat is just the syntax of how we're writing this. Sine squared of any angle is the exact same thing as writing it like that. Okay? We just write it the first way so we don't have to use parentheses all the time when we're squaring trig functions. Alright, so let's look at the cofunction identities. If we have a triangle and I have 30 degrees and I want to know the sine of 30 degrees, I could go to the other corner, 60, and the cosine of 60 would be the exact same thing as the sine of 30 because we're just going to the opposite corner. Okay? So what we're looking at here is sine and cosine will be the same if we use complementary angles. Remember, pi over 2 is the same as 90. So the sine of 30 is the same as the cosine of 60. If the two angles add up to 90, we can use sine equals cosine. Okay, this will work in the other direction for cosine and sine. It works for tangent and cotangent, and in both directions. And then our last pair of cofunction identities will be secant and cosecant. Cosecant and secant. All right? And then lastly, we have our even-odd identities. I want you to think about this triangle right here with theta. If I wanted to know the sine of this angle, it would be 1 over 2. And if we decided to just go negative with it, negative 1 and 2, our angle, which now we're going in the negative direction, so sine of negative theta equals negative 1 over 2. So you'll notice that when we change the angle from positive to negative for sine, the answer goes from positive to negative. Okay? However, what if it was cosine? Cosine in this problem would be root 3 over 2. We'd get the root 3 from the Pythagorean theorem. But if we flipped it and went cosine of negative theta, and we went down here, the x value stays exactly the same. So for cosine, if you go to a negative angle, your answer stays exactly the same. So for sine, we switch. For cosine, we stay the same. For tangent, we switch. For cosecant, we switch. Secant, we stay the same. And cotangent, we change. The way to remember this is that the only ones that will stay the same are the ones that involve cosine. Remember that secant is just 1 over cosine. It's the reciprocal of cosine. All right, let's flip the page and go to the back here. Explain how to use the fundamental trig identities to find the value of tan u, given that secant u equals 2. All right, we had a method for solving this from the last section, chapter 4. All right, if they told us secant u was 2, we would have drawn a triangle, drawn theta, know that secant theta is hypotenuse over adjacent, and so that would have been 2 over 1. Okay, so in this case we would have had 2 and 1. Pythagorean theorem gets us 3. So now we know that the tangent of theta, which again is opposite over adjacent, would be root 3 over 1, or just root 3. What we're going to do on in this chapter is have a different method. So the answer is going to be the same. Could use the first method if we wanted to. But what we're going to do instead here is go back to our formulas here. And I'm going to flip all the way back to this one here. We have a formula that involves tangent and secant. 1 plus tangent squared equals secant squared. Let me flip back real quick. And I'll write that down here. 1 plus tan, we'll use u, equals secant squared of u. So what we can do here is just substitute in what we know. 1 plus tan squared u equals secant is 2 squared. So 1 plus tan squared, and we'll just solve here for tangent, equals 4. Tan squared equals 3. So tangent equals the square root of 3. Okay? And in this case, we know that secant, since secant was positive, the tangent is also going to be positive here. Okay. You'll notice that we get the same answer using either method. All right, let's do the same thing here. Use the fundamental trig identities to simplify secant of x minus tan x sine x. All right, let's go back and see if we remember what secant equals. Remember that secant is 1 over cosine. So simplifying, what we're going to do here is turn everything into its pieces of sine and cosine. Tangent is sine over cosine. And sine is already in its basic form of just sine. We'll put a 1 underneath it so we have a denominator. All right, we already have a common denominator here, 1 minus sine squared x over cosine x. All right, if we flip back a ways, we have something we can substitute in for sine squared of x, and that's 1 minus sine squared x is going to be 1 minus cosine squared x over cosine x. Okay, we have a formula for sine squared x. These will cancel. Negative times a negative is a positive, so cosine squared x over cosine of x. Divide, and you're left with just cosine of x. All right, so we want to simplify that all the way through using sines and cosines wherever we can. All right, lastly, it's the additional notes here. We used this on the last problem. I just want to make sure that we see this explicitly. These are the 3 Pythagorean identities. You'll use them a lot, not in their original form, but moving them around. So sine squared equals 1 minus cosine squared. Also, cosine squared equals 1 minus sine squared. All I'm doing is moving things from one side to the other. All right, but a lot of times you'll need to substitute in just for sine squared, not sine squared plus cosine squared. So you'll want it by itself. Okay, so have that in your notes. Same thing on number 2, tangent squared. If we move the 1 to the other side is equal to secant squared minus 1. And same thing with cotangent squared. That's equal to cosecant squared minus 1. All right, so there you have it. Should be ready to get started with 5.1 next class.